semantic web technologies for the materials domain. And I'm going to do it by really looking at three standards organizations and their current activities. I'm not aware of any ASTM activity relative to semantic web technology development. I know that John Rumble is down in Florida right now, and he's sort of repitching, I think, sort of what he's done in the late 90s and throughout his career, and try to develop, a groundswell of support for the development of standards for materials databases. And so I think that's another foray into ASTM to try to get them to take a closer look at this kind of activity again. First, I'm going to start out with Technical Committee 184. They're in charge of automation systems and integration. And they consist of 4 subcommittees. The one that we're going to focus on is subcommittee number 4, entitled Industrial Data. If you just take a look at the primary standards that are associated or maintained by subcommittee 4, we see a couple that are really relevant to semantic web technology. The one we're going to focus on today is ISO 10303, which is Industrial Automation Systems and Integration, Product Data Representation and Exchange. I had an email exchange with Norman Swindells, who is close to this particular standard, and he indicated if you swap material for a product, you have a lot of the same technologies that would be applicable to the materials domain. And obviously, if you look at ISO 8000, right above that, it talks about data quality, provenance, accuracy, completeness, the sorts of things that we care about. And the nice thing about standards is they basically embody a lot of knowledge. Basically, thousands of hours of people's time and energy and knowledge are captured in a lot of these standards. It's a matter of trying to figure out what you can extract that's applicable to current and today's problem. I highlighted here what ISO 10303 is all about. It's a standard for computer interpretable representation and exchange of product manufacturing information, predominantly geared towards the CAD community and that sort of thing. But the focus was interoperability across all these different pieces of equipment, software applications that dealt with product data. And again, replace product data with material, and you're sort of in the ballpark of what this at least a lot of what the content is associated with this would be applicable to materials. And if we look at ISO Part 45, the 303 Part 45, it deals specifically with material properties. And then 235 deals with an application protocol for materials information for the design and verification of products. Now, ISO 10303 came out, I think, first in 1994. And this was involved, I think, a little bit later. I'm not exactly sure what time, but they definitely got involved in the late 90s. And then there was an activity that started around 2009 called Future Step. And it looks like it was an activity geared towards sort of modernizing this particular standard, which has, frankly, hundreds of steps associated with it. And the modernization included trying to express things in a different way, trying to utilize some of the semantic web technologies that are currently in place and have matured over the last 14 years or so. And if we look at Part 45, toward the bottom where it's called Elements, what does that ISO standard care about? It cares about specification of material properties, association of material properties to a product, qualitative, quantitative conditions, and validity of the material's properties, material properties of the product. A lot of the same things we would care about in whatever system that we create for materials data, for a materials data infrastructure. And if we look at Part 235, what do they care about? Descriptions and definitions of manufactured product, sample of the product, description of composition of the substance, and so forth. I could just go down this list, and pretty much everything that's bold here is something that we care about relative to ICMSE. So this is probably, this last time it was updated was 2009. So this kind of leads you to think, well, maybe there's something in here, some way that they describe the informational construct, the data model, etc., that would be applicable and something that we could extract and apply to semantic web technologies. So how do we kind of know we're going in that direction? Well, one is it's pretty overt. Some of the more recent ISO ISO specifications talk about, like, for example, Part 8 here for implementations, methods for the integration and distribution system, web ontology language implementations. So there's folks on that committee and folks working within that committee that understand that there could be a home here for semantic web technology. And if we look then at the bullet below that, future step, which is kind of now called, it seems like, idiom, integrated data interchange, integrated ontologies and models. This is where we're really trying to exploit the semantic web technology. And there was a draft idiom specification that was drafted up with NIST itself in 2010. I can't really tell exactly where they are today. I think Norman Swindle's indicated that there's still work, and basically they're trying to convert it from kind of like one data model called Express that's used in that community to some of the W3C standards. And this shows something out of that idiom architecture. And this is pretty much directly from that. And what you see in the upper left-hand corner is the catalog of the actual language dictionaries. This is basically just common vocabulary. This is so that everybody, when they say modules, Young's modules, whatever it is, they agree. This is the definition of that particular term. This is required because when you build an ontology, you're going to take some of those terms that are associated with that glossary and incorporate them into the ontology. And those glossaries provide definitions, which is meaning. So then you want to make sure your ontology, which it's supposed to imply, is you have a meaning associated with this ontology, or that is expressed based upon the construct of the ontology. And so the first thing that needs to be done is we have to create natural language dictionaries. And there's activities sort of out there that are moving forward in that direction. I'd like to thank ASM and Scott Henry for providing the ASM glossary for their ASM Handbook 21, the Composites Handbook. We took that glossary and put it into triples. I think we only have book 5 and 17. If it's not in there already, it's going in shortly. And so this is really intended to provide a place where somebody could go to see an example of a vocabulary sort of in the process of being developed. And I don't know how many terms are in there currently.
Over 2,000.
Over 1,000?
2,000.
Okay, thank you. And so we're working really here at the Noesis Center with ontologies. We're looking at OWL, W3C recommendations, and then working also to create that natural language dictionary. We haven't really done much with any of the other activities that are associated with the idiom architecture specification. Now if we move to a different standards body, the European standards, they had a workshop, and their workshop is typically 6, 8 experts that work for a certain period of time, 16 months, 21 months, that sort of thing. So in this case it was 12 months. This was a workshop that they put together, and because they wanted to focus on interoperability of engineered materials data. So it's materials data, and they want to be able to flow this materials data from application to application to application without regard to what the application is. And when I say application, I'm talking about software application. It could be an MTS control software for an MTS frame. It could be, putting model into putting materials data into a finite element model. It could be a model that predicts the residual strength associated with a damaged composite or the failure mode of a damaged composite. It doesn't matter what it is. And they decided to go about it by looking at the standards that are currently out there for ISO, for mechanical testing, and to see if they could develop ontologies and some other things relative to those particular standards. And so they chose one associated with tensile testing out of ISO, and sure enough, they said, yep, it's well suited for schemas, but that wasn't a surprise. It already had CSV files that could be associated with it. The existing terms and definitions associated with that standard, so we're back to vocabularies and definitions. It was a good place to start for a concept thesaurus, which is, again, we're just talking about a list of terms that maybe were synonyms or terms that are the same as one another. But in order to turn the thesaurus into an ontology, a higher level framework needed to be put in place. And so it was either that idiom framework, for example, this, or something that would be associated with NIST's product information modeling framework, but some other framework needed to be put in place to really make this come to life. And so they said it started a second workshop. In this case, it was a 21-month workshop. It was going to end sometime this month, and they're going to come out with their report this month. If you remember, you'll get to kind of see the report before it goes public. But this will begin to then show some of the results associated with that activity. So their objectives were to start where the last workshop left off and establish a unified standard representation for engineering material tests and their results, along with a proof of concept. All right, show me that this thing works. And so they have to host it somewhere and so forth. They're going to host it looks like, at Vermont, at Technical Working Activity. That didn't sound right, but it's basically a group of folks, at number 35, that are associated with materials representation. And what's going to be presented there, or I believe what's going to be hosted there, will be a vocabulary. We've already exchanged some emails. Theirs is sort of expressed as spreadsheets. Ours will be RDF, but we'll exchange and kind of put them both in both places. They want to design, define an ontology and reference implementations. A guy named David Leals, our ontologist, I think is also associated with the other international, or with the ISO standards body. So here you have kind of two standards bodies kind of going after the same objective, kind of utilizing the same technology, W3C or semantic web technologies. So it kind of makes you think, well, maybe that's a direction that's valid. It doesn't totally validate what we're doing, but it doesn't, it's for sure not invalidating what we're doing. So we're going to work hopefully with those folks and continue to push this forward. And this is sort of an example of what they sort of envision for series. In this case, it shows a material test ontology, it shows material ontology, and then the flow of data. So in this particular case, you have a supplier flowing some data to a test house flowing that data back to the supplier flowing that data to the OEM, and it's transparent. The passage of information in the background is transparent. There's no ETL, extract, transform, and load, right? There's none of that. There's no special procedures that have to be written. I mean, that's the vision here anyway. So all that wasted effort and frustration that typically goes with moving data from A to B to C begins to go away. And if you look, what I want to do is just kind of throw this in here real quick. You know, there is no such thing as original thought anymore. You know, I sort of came up with the triplets, like looking through time. So I sort of came up with this triplets concept, and I patted myself on the neck. That's pretty original, right? And then I looked at Mill Handbook 17, and Reagan Mill Handbook 17 is something that says raw materials, manufacturing product, finished product, right? It's the same thing as what I have here, which is, in my case, is materials products are subjected to a process which yield a higher value product. It really isn't. It isn't anything special. But as I started to look at these standards and talk to other folks and so forth, what began to emerge was that seemed to be a common foundational concept. And as a matter of fact, after speaking with David Leal, he said before they even created, and I hope I'm not putting words into his mouth, but before they created hierarchies or taxonomies and that sort of thing, they focused on that top process, right, that top box in the chart, which is basically the same thing. You have a process, you have a product goes into the process, you have a product coming out. If we look at one of the standards, ISO 103, Part 235, it really is basically the same thing. You have a process operation. Okay? So you have a process value, you have a process by, a process operation, and yield is produced to the product value. So people have thought about this. They've developed data models around this. So there's got to be something in these standards. There's got to be something in these workshops, the CEN workshops, that are relevant to what we're doing. And we just need to capitalize, I think, on a lot of that information, especially if both of those bodies are moving towards utilization of semantic web technology. And this is sprinkled throughout all of this. And I would say, and I could be wrong on this, but if there's a guy, Dr. Alden Lima, and then Dr. Kerry Campbell, and Ms. Kerry Campbell's material science, Alden Lima is working to develop ontologies. He's a computer science guy. He worked with an ontologist for about a year and a half, and they created an ontology, and he wasn't real satisfied at the end of all that. He had a couple of French researchers working with him. He wasn't real satisfied with their ontology at the end of all that. And so they started to move toward natural language processing, I think, to help extract concepts and so forth. And so he's kind of moving in that direction. So of the folks that I know working materials, ontologies, or those kinds of things, I'd have to say that Alden and Perry are probably the ones with the most experience and the most lessons learned, which makes it easier for them to kind of project what they might do in the future. But if you look at this, you see a lot of the sorts of things that we've been talking about. We have the ontologies, and this is the semantic web, the W3C that's associated with it. They moved off RDF. They found that RDF, and this is my understanding, there were some limitations associated with it. And I can truly appreciate that, just a little bit of time that we've sort of worked with it. I can say something like porosity decreases strength. That's a great relationship that can be captured in an ontology. But if you want to go beyond something that's binary, it's very difficult. You have to spend some time really thinking about it in order to try to cast it into an RDF, which is a binary relationship. So I believe that's one of the reasons that they moved into other data models, graph-based data models that don't have that limitation. So as I was talking to somebody in the break here, NIST, they're focused on CalFat and metals, and they're going deep. And my sense is, it's geared more towards the fundamental science. It's not a complete truism, but it's kind of going in that direction, right? But if they go outside of the current standards suite that are available for semantic web technologies, that makes adoption by others a little bit more difficult. It solves the problem, though, of being able to create these very expressive relationships between all these materials concepts. Materials parameters, materials phenomena, materials facts, etc. On the other hand, I kind of think I'm putting on my engineering hat over here and saying, okay, we have W3C, it's mature. Maybe there's still a lot of value to be had by utilizing those tools for a lot of our material information. Not all of it, not all the relationships. We can't capture all the expressive. We can't express the relationships as richly as we would like to, maybe using OWL. Maybe there's enough there such that there's value to be had. And everything I've seen today makes me think that that's the case. But I would kind of put that more toward the engineering side. And maybe it's not going to be able to go deep into the fundamental science side. But that's kind of speculation. And ignorance, not having very much knowledge about some of these capabilities. The other thing that's pretty great that's going on out there is, I believe this. I've seen spreadsheets. I haven't followed up with anybody in this to see if this is the case. But they have basically a center of excellence, and they've been funded. I think it's around $14, $15 million for advanced materials to support MGI. And they want to come up with representation and interoperability of materials data. They want to be able to have interoperability of systems at different scales, so different time scales, different length scales, nanometer versus millimeter, that kind of thing for length scales. And then quality assessment of models, simulations, and materials data. And they have 2 pilots that are associated with that. So, final slide, observation and opinion. I think that there's something in the ISO and CEM standards that bear further work to look at, because I think there's just a lot of knowledge that's captured by those guys. NIST has significant experience in developing ontologies for materials, and they're taking a grander stage, as it were, because of the MGI initiatives. And I think they're probably able to develop on-target future approaches. Whereas, if you're just starting out, you're just learning, how to put this thing together, you're going to make a lot of the same mistakes. And this is go talk to them and figure out exactly what they've done. And I think they're going to have a strong voice moving forward. And the number of participants in the U.S. developing solutions for federated materials data, I think, is poised for significant growth. Simply because there's a lot of resources that are starting to go into this, and the contracts and so forth are just beginning to catch up. We have a SIBRA that was just awarded, so there's 3 phase ones. This is kind of what we're doing. We have a center of excellence. I think that was $500K per year for each of the participants. FOS ourselves and Light from the university. We got a couple of FEPs focused on ICMSE. Terry Wong is associated with one of those in handling sort of the data architecture and so forth. So we have things that are either directly addressing materials data and interoperability, or we have things that are nibbling on the edges and using different technologies, which is legitimate. We have to do a comparison as time goes on, understand the pros and cons in order to enable ICMSE. But I have a feeling it's going to be kind of tough to keep up with everything that's about to happen in the area of federated materials and
triggers interoperability.
Any questions? Still waiting. All right. Next, for up for going into the different breakout sections. Technology get adopted and tested out, like stress testing, find out where it breaks and where it can excel. All right. With that, I would simply just like to open it up to anyone who might have a comment, or a question, or observation. Very good. This formally concludes the workshop. If anybody does want to continue a discussion, on site here, I'm going to be here for the rest of the afternoon. So if there's something you want to talk about or scratch out